Okay, now we're going to do an experiment with this question to see what would happen if part of our region between two curves lay below the x-axis and part of it lay above. Do we still get that result that we're used to of seeing that integrals down here are negative? Well, we know that the area between these two curves in these bounds from 1 to 4 was 4.5 units squared. So let's think, what would happen if we actually dropped both curves down a bit? Well, let's drop them down, let's say 2 units. All right, so this line y equals x would come down here and be y equals x minus 2, wouldn't it? And the parabola, instead of being y equals x minus 2 all squared, how do we drop it down to? Well, we can put a big minus 2 at the end. So it would come down something like this. Now, we're still going to have an area between the two curves, and my drawing is actually not that great. Let's fix it a little bit. Now, you can see here that we're still going to have very similar shapes. Everything's going to line up vertically. Are our two areas going to be exactly the same size? Yes, you can tell that they are just from sheer logic. If I've dropped the parabola down and the line down both by 2 units, the shaded area is not going to change in size, so we should be expecting it to still be 4.5 units squared. So let's go through and do our working with this new question and double check, do we get negative answers or do we actually just get this? Because that would be a good way for us to decide in the future, if we've got a shaded area that's sitting above and below the x-axis, is there anything special that we're going to need to do with it? Okay, so here I've written up the second question. We've dropped down our parabola by 2, and we've also dropped the line y equals x down by 2. And I've redrawn our area. Now we know that the area of our last question was 4.5 units squared, and we're expecting this one should be the same by rights because it's literally just dropped down a bit. So we want to check and see if our working gives us that same result. Okay, so I've gone ahead and found my intersection points using the same method as before. I've let this equation, if y equals this and that must equal each other, and I've solved it. And I've got the exact same bounds as I found before. The working looks a little bit different, but we're still working between x equals 1 and x equals 4. So the next step then is to say, all right, the area, according to our rule, let's just see if it works, even when we're a little above and below the x-axis here, we need to find the integral between 1 and 4 of the higher up function minus the lower down function. Now you can figure out what that is and bring it together over on the side and then write it here. Or you can write down what you're doing and then tidy it up as you go. It doesn't make too much difference. I'm going to work in here so it's really clear what I'm doing. So the upper line is x minus 2. That's its y value, x minus 2. But then we need to subtract the parabola, which is all of this. Now, we don't want to make a classic sign error, so I need to put all of this part in brackets like that, because we're taking away that whole part, and we need to integrate it. Okay, next step, I'm not ready to integrate yet, I need to tidy up all of this. So keep on writing this part. Let's expand out what it is I'm subtracting. Well, I need to subtract x squared minus 4x plus 4 minus 2. That will give me plus 2. I can do that part in my head. That makes it a little bit simpler. And now on the next line, let's bring it all together. We've got minus x squared, and we've got x plus 4x, which is 5x. And we've got minus 2, which is minus 4. Now, I can almost basically stop there because if you look back at our last example, this is exactly the integral that we found, minus x squared plus 5x minus 4. And the bounds are exactly the same. So you can see that the answer that's going to come out here when I just blindly apply my formula, ignoring what's above and below the x-axis, it's going to work out. It's going to give me the right answer. So here's the take-home point. If you are finding an area between a curve and the x-axis, just a simple old question like that, and it's below the x-axis, or if you're dealing with the y-axis and it's to the left of the y-axis, you're going to get a negative number for your integral and you've got to take account for that when you're finding area and say areas have to be positive, so I'm going to have to fix it. But when you're finding the area between two curves, because we're subtracting one from the other anyway, it actually deals with all of those calculations in itself. So we don't even have to worry. We can just do the upper curve minus the lower curve, integrate it, follow our steps, and the answer that comes out will be the area. So it's actually quite a lot easier finding these combined ones than it is finding a simple one. There's less to do, just follow the formula.